Okay, so now let's move on to question 2. So here we see our model M, where in our first state we have P, Q, and T atomic propositions, and we transition. You can see this is a Kripke structure. We have no label on our transition. Over to the next state where P, Q, and R are true. To the next state where P and S are true. And the final fourth state where P and R are true. This then transitions back to the state where P, Q, and R are true. So our atomic propositions are P, Q, R, S, and T. So we have 4 states, we have 5 atomic propositions, and we have 1, 2, 3, 4 transitions. So the question is, once more, which of these questions holds true? So, first question is G of P. So is it true in this model that P is always true? Well, let's see. Let's check. In state 1, P is true. Correct. In state 2, P is true. Correct. In state 3, P is true. Correct. In state 4, P is true. So, in every state in our model, P is true. The atomic proposition is true. You can assume, let's say here P, Q, and T, that all these are true, you assume anything not here is false. So in this case, S and R would be false for state 1, and so forth. Next question, eventually T. So is there a path, or eventually, a linear path, where eventually T is true? Well, let's see. In the very first state, P, Q, and T, T is true. So we already know it immediately that this is true. Now, let's move on to our next problem. Always, eventually, S. So is it true that always, eventually, S? So we start here. So first of all, is it eventually S? PQT? No. PQR? No. PS. So S is true in state 3. So is eventually S true? Yes, it's true. Now is it always true? Well, you can see you can only transition. You have to transition through S. So yes, it is true that always, eventually, true. There is no other path. You have to traverse this path. Now, let us say if you went PQT, went to PQR, and this transitioned back to PQT, then always eventually S might not be true, because you could transition to this state and go back and forth infinitely. But the fact that the successor PQR goes to P of S, and then to P of R, and then circles back, on this linear path, you will get to where S is eventually true. So let's move on to part 4. So this is G of T or F of Q. So now we've seen our Boolean operator here. So we have an OR here. So what is this? It's always true that T is true, or eventually Q is true. So let's do always T. So state 1, T is true, yes. State 2, T is not true. So this is false. Now we have an or, eventually Q. So P is, but look, Q is true already in state 1. So this is going to be true, because as we know in or, if one of the propositions is true, so you can assume that there is a bracket around this. So if this is true, then the whole clause is true. So this is also true. Now, the next question. X, Q implies or until S. And this is a more complicated formula. So, you may be looking at how do we go about solving this type of question. And I'll pause now because I have to draw a table. Okay, so let's take this step by step. So we have 3 atomic propositions here. We have Q, or, and S. So this is the formula we're working on. And here is our model. So let's say we said this is state 0, this is state 1, this is state 2, this is state 3. So 0, 1, 2, 3, and 3 goes back to 1 in this transition. So what state is Q true? So we'll start with Q. So Q is true, we'll highlight in blue, in state 0. It's true in state 1. And that is it. We'll leave the other 2 blank. We'll do the same for or. Or is true in state 1. And it's true in state 3. And for S, you see it's only true in state 2. Sorry, let me get rid of that. Now, or until S. So when you see something like this, you start with the innermost bracket. So or until S. So we'll start with this. So where is or true? It's true in state 1. Is or true strong until, remember when you don't see U, it's a strong until it's yes. So is or always true until you meet S, and S is always found. So we're in state 1. Or is true, as you see here. Then we go to state 2. S is now true. So if S is true, then or must not be true, and yes, that is the case. But we also have or is true in state 3. So again, we check this, is it or hold until S? So it's true in state 3. State 3 transitions back to state 1. We already know from state 1 that or until S holds. We just did it. So this is true in state 1, state 2, and state 3. So explain that again. An or is true in state 1. And you go to state 2 in transition, S is now true and or no longer holds. So that's or strong until S. So it holds in both state 1 and state 2. When we're in state 3, or holds, and we transition back to state 1. Now we know state 1 already holds. So therefore S3 must hold. So that gives us these 3. Next, we move out till Q implies or US. So we know it holds in states 1, states 2, and state 3. So if Q is true, it implies that when or until S is true, and when Q is false, then it doesn't matter what or until S is, it's going to be true anyway. However, if Q is true and or until S is false, then this does not hold. So essentially in state 0. If Q is true in state 0, well, let's see. State 0, Q is true. Or until S is false, as we've seen in state 0. So therefore this is false, empty. Let's go on to state 1. Q is true, and or until S is true. So this holds here. Q is not true in state 3, so it doesn't matter what or until S is, it's going to be true. And again, Q does not hold in state 4. So again, it doesn't matter if or until S holds, it's going to be true. So we get actually the same table as we did above. So again, let's go through this one more time. In state 0, Q is true, or strong until S does not hold. So this does not hold. State 1, Q is true, or until S is true, so true. State 3, Q is false. Anything implied or false, you're going to get true. In state 3, Q is false, and again you're going to get true. So now we go down to our final proposition. X next Q implies or until S. So next Q implies or until S. Where does Q implies or until S hold? States 1, states 2, states 3. This means X is next. So if you're in state 0, it must hold in the next state. If you're in state 1, it must hold in the next state. If you're in state 2, it must hold the next state, which is X3. So in state 0, of P, Q, and T, where Q is true, does it hold that in the next state, Q implies or until S? Well, the next state from S0 with a transition is S1. It holds in S1. So we say it holds here in S0, or it is. In S1, it holds in S2. In S2, it holds in S3. And in S3, remember we transition back to state 1. So it holds in state 3. So we've determined that this is in fact true. You see, all the states this holds. In the next state, Q implies or until S always holds. So this is true. Now, since we've only said next implies Q implies or until S, we actually only need to do it for state 0. We only do it from the initial state. So you assume that the first state here is the initial state. If there was no initial state, it would still hold because it holds everywhere. So let's say if you were to say put a G in front of that, so say that this always holds, it is true. If it was eventually, again it was true. And if it's just X, it's also true. So that is how you would work a question like that. So even though it looked like it wasn't going to hold, is when we added in our temporal operator, we actually saw that this actually does hold. And that is question